Hello. Today we are going to look at some general concepts about trees and computer programming. What is a tree? Well, you can describe it as a non-linear hierarchical data structure, which consists of nodes and edges, and there's only one path to access each node from the root. That all sounds confusing. What that means is, suppose you have a value that you want to store in the tree. Normally you might store it in a list or an array, but we're going to store it in a tree. Well, in addition to the value of that, you would also store other items with that variable, which consists of branches that can lead to other nodes. It's sort of like a linked list, except that it's non-linear, and that it doesn't necessarily just go one way. It can branch off in several directions. Here's an example. So you can see it kind of looks like a tree, except it's kind of upside down. If you were to flip this the other way, it would sort of look like there's a base, like a trunk of a tree, and it would be branching off into a whole bunch of separate branches. The first node is the root node. Like this would be similar to the trunk of a tree. The root node is where the tree starts, and the unique property is that it has no parent attached to it. This is generally the first node you would read of a tree. In this case, A is the parent of B, C, and D. Likewise, B is the parent of E and F. C is not the parent of anything. D is the parent of G, H, and I. And E, F, G, J, I, and C are all leaves of the tree. Leaves means that they are nodes that do not branch out any further. If it did branch out to something else, then you would think of it as a branch. But if it doesn't branch anywhere else, then that's like the end of the branch, which on a real tree would be like a leaf. Now B, C, D, and A are all B, C, D are all of A's children. And also E, F, and are all B's children. E and F can be called siblings because they're sort of related to one another. They have the same parent. J is H's only child because J has no other siblings and H only has one child. There are some other properties you can consider. A tree with n nodes, n being a number, generally has n minus 1 edges. That is, edges being the connecting points on the tree. This makes sense because every node except the root has exactly one incoming edge to it. A root means the nodes without a parent. Leaves means nodes without children. Siblings means nodes that have the same parent, like I said. Ancestors and descendants. In this example here, you can say that A is an ancestor of B. B is a descendant of A. If it helps, you can consider this like a family tree, where the top of the tree will be the furthest descendants, the furthest ancestors, and everything coming from it is a descendant. I'll use another example to clarify that. A is the ancestor of all the other nodes in this tree that we have in front of us. J is the furthest descendant of the tree, being the descendant of H, D, and A. And there you go. Now, if you are talking about the length of a path of the tree, that's the number of edges that must be followed starting from one node to the last node until that node is reached. The depth of a node is considered to be the number of edges that the root is away from a node. Note that the depth of the root, that is the node at the very top, is always 0. The height of the node is the length of the path from the node to the deepest reachable leaf from that node. Note that the height of the tree is always the height of the root, that the two heights are identical. The size of a node. The size is the number of descendants of the node plus the node itself. Note that the size of the tree is also the size of its root. Here's another example. The length of the length of a path from A to B is 1, and likewise the length of the path from A to E is 2. The length of the path from A to J is 3. The depth of each node, so it corresponds to this picture I have here. B, C, and D would all have a depth of 1. E, F, G, H, and I would have a depth of 2. And J would have a depth of 3. And A would also have a depth of 0. Now recall what the height of the node is. I talked about this, I think. That is the length of the path from the node to the deepest reachable leaf from that node. Well, here's an example of that. The height of node J is 0. The heights of E, F, G, I, and C are all also 0. The height of the node H is 1. The height of node D is 2. The height of node B is 1. And the height of node A is 3. The height of the total tree is also 3, which is equal to the height of the root. The size of node J is 1. The size of node A is all the nodes in the tree plus 1. Or rather, all the nodes that that descend from A plus 1, which would be equal to all the nodes in the tree. In this example, that's 9 plus 1, which is 10. Now, if you are implementing a tree yourself in programming, there are different ways to do it. The problem with a tree is that you don't know how many ways it could branch off. If you have a node, it could have 1 branch, it could have 2 branches, it could have 10 branches, it could have 152 branches. So that's a general thing that you have to consider when you're making it. In this case, you have 2 choices. You can have a linked list where each node would connect in the linked list to something else. So for example, in this tree I have here, A would connect to B, and B would have a linked list containing C and D. So it's a linked list of linked lists. You can think of it like that. You can also store them as an array, for example, as we see below. Okay, that's all we have to talk about trees. Thank you for watching. I hope you learned something. Good day.